Angelina Jolie made headlines early last year because she decided to have a double mastectomy. This was surprising to a lot of people because she wasn't actually diagnosed with breast cancer, but her mother was. Knowing this information, she feared that she too may succumb to the disease. So she decided to take a biological test. She found out she had an 87% chance of acquiring the disease. So her and her doctors decided that surgery was the best course of action for her. This is an example of how a preventative treatment plan was decided based on a patient's individual needs. Despite new tools for treating and preventing breast cancer, it remains the second leading cause of cancer-related deaths in females. But not all cancers are created equal, so it's difficult to decide a treatment plan that is effective. The most difficult types of cancer to treat are those that actually spread to other organs, so we want to be able to prevent this from even happening. So before you decide a cancer treatment, you want to be able to predict what a cancer might do next, and then you want to make sure the cancer is all gone after the treatment. One of the ways we can do this is through molecular imaging. Typically, when we think of looking at breast tissue, we think of a mammogram. In this example, a patient actually tested negative for a particular type of cancer using the mammogram. However, using the molecular breast image, the patient actually tested positive. The reason for this discrepancy is because before a cancer cell actually becomes a tumor, a biochemical change in the cell has to happen first. So we're able to detect this change using molecular imaging. One of the ways we can do this is to look at the particular enzyme that a cancer cell produces. So for me, I'm interested in an enzyme called cathepsin B. So when a tumor wants to grow and spread, it actually produces a lot of this enzyme. This molecule here, it's special because it can actually fit into the particular binding site on cathepsin B. So using chemistry, I'm able to attach different radioactive atoms to this molecule, so we can actually detect it using specialized cameras. Although the thought of injecting radioactivity into a person, it might sound pretty scary, but we actually use very little, so there's no harm to the patient at all. So far, I've been able to test this compound using cells and mouse tumor models. So just imagine, after diagnosis, being able to decide what the cancer is going to do next, decide on an effective treatment plan that's individual for the patient, and be able to check how that treatment is working, all by just taking a picture. Thank you.